passing a class to a function works just like anything else that we've been passing in to our functions. There's just a couple things I want you to keep in mind when you do this. So let's go to CLion and see what it looks like. So you can see here where I did the printout of what's in my variable. If we wanted to, like anytime you're going to do repeat code like this, what you should be doing is making a function out of it. So what we're going to do is cut this, right? Easy for me to say. And then we're going to come into our items, and we're going to make a function that I'm just going to say void, and we're going to say print items. And we're going to paste this in here, and we're going to pass in our items, right? So we're passing in an items class, right? That's the data type of the item we're passing in. And we're going to just call it item, or we'll just call it I. And so we'll change all these just to I. And it's going to do the same thing, right? So it just is printing it, and we need to also add this to our header file. And you'll note I kind of should, what I should do is, and let's do that just because we should have another source file. We're going to call these helper, and we're going to make an associated header file with that, right? So what we're going to do is, instead of having this in the because it is not an items one, right? We're going to put it in the helper, and we're going to put this in here. We don't need the definition. We just need to, we're making a prototype, right, of it. And you notice it's not happy because it doesn't have items. So we need to include our items.hpp. So now it's happy, right? And we need to do that same thing in our helper file, right? And so that it's happy and it can do our print, right? And you notice like this is different. This is like how we've been normally doing our functions. This is just a normal function. It's not actually in the same resolution scope as our items here, or as our class, right? It's not a function in our class. That's why we have it in a separate file. And so instead of doing this, what we're going to do, right, is to print our items. We're going to say print items, and then we're going to pass in new items, and then print items, my items. And you see it's not happy, and it's because we also need to add the new library here, or the new header file in here as well, include, and we have our helper HPP. So now it's happy, and they can see it. And so basically, right, we pass this in just the same as we did before of the new items. And the reason why I want to point this out to you is because what we're going to do is we're going to compile this, and then we're going to run it. And I want you to see that it did something, right? This is us. Let's go through the code and just make sure that we know what's happening, right? We created my items. We set it up as a cloak, and then we created the shoes, and we changed it to boots. And so then we came in and we did, you'll see we have a destructor for boots. And then we have the cloak, like, so we say boots and weight, and then we have the destructor for boots. And then we have cloak and weight, and then we have the destructor for cloak, and then we have the destructor for boots again, and we have the destructor for cloak again. And the reason we have these extra destructors is because it actually created these items again, right? When we did this function here, and we passed in our class as an object into our function here, the system said, oh, okay, let's go create this new class, this new variable I in memory, right? And it's going to create that, and it's going to then do all the work for it. And then when it's done with this, when it gets to the end of the scope of this particular function, then it's going to go and destroy it. And just so that you realize that that's what's happening when you're doing this. So that's why what would be better than sometimes than this, right, is instead of having it be a separate function like this where you're going to have to pass in the class. And one of the things that we could test, right, just because I want to see how this works, is I'm going to try to change the name of i.setName, and I'm going to just say, you know, a shirt. And so it's going to set that one to shirt. And so when we come back out here, when we compile this, right, and we run it, you're going to see, right, it came in and it made shirt with a weight 1.5, and then it destructed the shirt 1.5, and then it shared weight 1.2, and then in destructor it destroyed the shirt, right? But then you notice it destroyed boots, and then it destroyed cloak. You notice that it didn't destroy the shirts two more times, and that's because just like other address spaces, this it's not the same, right? You would have to pass in the pointer to the original item for it to not have it be a whole new address space location that it made in for it. And so that's just something to be aware of, right? That sometimes it might be better to do things a slightly different way. Like, right, if we wanted to create a print class, we came into our items here, and we have our setters and getters, and we could also make a void print, and we could put that same, right, we could come in here and we could come and do void print. We have our items, and then we could have that same line that we did here, and we go back to our printer, and we could just do it, but we could just say, and we wouldn't even need these, we could just say name and weight. And so now, right, when we compile, we need to actually call it, right? So those are the print items, and so we could say new items dot print and my items dot print. And so when we do these, you're going to see we didn't add two more destructors, right? We still only have the one, and that's because we didn't have to go create a whole new address space for it. And that's kind of the benefit of a class, is that we created this and we were able to print out the information just by calling a member of that the method from that one class, and it printed out the information without having to add more to the memory, and it just saves memory processing. It saves time. You don't have to create it and destroy it. So there's a lot that's saved by having it built that way.